Hello, and welcome to a little review on trigonometry, right triangle trigonometry. So the first thing I want to review is just what are these trigonometric ratios and what do they mean? So in trigonometry, what we are doing is we are relating the sides of a right triangle to the angle of the right triangle using ratios. So there's actually 6 trigonometric functions, but in this class we only talk about 3 of them. They are called sine, cosine, and tangent, okay? And these are simply ratios or just fractions relating 2 sides together in relation to where an angle is, okay? So the way that we remember this is using a little acronym called SOHCAHTOA. So, TOA. I like to write it like this because what these are little fractions. So if you write it like this, you can remember which part goes on top and which part goes on bottom. So TOA. So this is for sine, this is for cosine, and the last one is for tangent. So what it means is this. We start by looking at the angle that we're talking about. In this problem, we're talking about angle X, which is right here. And what we do is we label the triangle based off of the location of that angle. So across from that angle is what we call the opposite side, okay? So it's opposite, but I usually just put an O. Oops, let's do this. There we go. All right. That is across. Then we have the side right next to the angle. This is what we call the adjacent side. Adjacent means right next to. So I put an A for adjacent. Now the side that's across from the right angle, the slanted side, is always called the hypotenuse. And so now you can see where these letters are coming from. The O means opposite. The H means hypotenuse. And then the A means adjacent. So if I said, what is the sine of angle X? The sine is opposite over hypotenuse. So that is 15 over 17. Cosine is adjacent over hypotenuse. So the adjacent side is 8. The hypotenuse is 17, so the answer is 8 over 17. And finally, tangent, we say TOA, that's opposite over adjacent. So that is 15 over 8. So that's how you would just find sine, cosine, and tangent of an angle if I gave you a triangle with all 3 sides. But another thing that we can do with this is find missing sides of triangles. So I'm looking at worksheet 8. I'm going to do a couple problems from worksheet 8 just to teach how we can use trig to find a missing side. So the first one I'm going to do is number 3. So they give me that this angle is 34. From that angle, this 11 is the opposite side. They want to find GH, which I labeled with an X. That's the hypotenuse. And then the side HJ is the adjacent side. Now, what you need to do is figure out, should I be using sine, cosine, or tangent? And that's all based on what you're looking for and what they give you. So they give you the opposite side, and you're looking for the hypotenuse. So I usually write those down, O and H. And then I have to figure out, is that sine, cosine, or tangent? So this one is so it's sine. So then we set up an equation once we figure out that we're using sine. Now, it's always sine, cosine, tangent of the angle. So it's going to be sine of the angle, and we know the angle is 34, equals opposite side, that's 11, over hypotenuse, that's what I'm solving for, that's the x. All right, so we could like multiply this x over to the other side and then divide over the sine of 34, but I like to use a trick for this one. Whenever the x is on the bottom, what you can do is swap it with the sine of 34. So it looks like this. X equals 11 divided by the sine of 34. Okay, and then we're just going to put this in our calculator. It's really a calculator problem. Okay, so I'm going to type this exact thing into my calculator. I highly recommend using test mode. Okay, because it's really easy. You're just going to hit, it's already on degree mode, and so I'm going to hit 11, and then I'm going to hit divided by, and then sine of 34. And you can see on the right side of the screen that it says equals 19.67. 19.67 is the answer. All right. I'll do one more with you here. Let's see. All of these look like they're 25. So let's see, this is adjacent, this one is opposite, and then I'm looking for the hypotenuse. Okay. So I have the adjacent, I'm looking for the hypotenuse. That one is cosine, ka. So I set up my equation, cosine of the angle equals adjacent 33 over hypotenuse x. And since the x is on the bottom, we switch. 33 over cosine of 25. Oops, I'll use this calculator again. 33 divided by cosine 25. 36.41. That's the answer. All right, I'd like to do one more because I want to show you what happens if x is not on the bottom. So let's do number 6. So it gives me that this little angle here is 12. All right, so the opposite side is what I'm looking for. That's x. And then the adjacent side is this 83.1. So O and A is tangent, TOA. So tangent of my angle, 12, equals opposite x over adjacent, 83.1. Now this time we don't do a switch because the x is not on the bottom. All you want to do is you want to get rid of this divided by 83.1. So I'm going to multiply it to the other side. So that cancels. And all I have to do is type that in my calculator. 83.1 times the tangent of 12. 83.1 times tangent of 12. And I get 17.66. And that's it. So now we're going to move on to inverse, okay? So this is how you find a missing side of a triangle. But if I was looking for a missing angle, okay, then I would have to use something called inverse trig. So here's an example of this. This time it says solve for angle x. Okay, so still from angle x, the opposite side is 10. Adjacent side we know nothing about. Hypotenuse is 12. So since the ones I know are opposite and hypotenuse, I'm going to use sine. So I'm going to set this up, sine. Remember, it's always of the angle, but this time I don't know what the angle is. Equals opposite, 10, over hypotenuse, 12. Now, this part is kind of weird. What I need to do is I need to cancel out this sign so that I have an x by itself. And just like if I had 5x equals 10, to cancel out this 5, what I do is I divide it. But the reason I divide is because the inverse of multiply, because this is 5 times x, is divide. The inverse of sine, this is not multiplication. The inverse of sine is literally just called inverse sine. It looks like this. And so all I'm going to do is do the inverse sine to both sides of the equation. Okay? And this cancels out the sine. It leaves just x. On this side, I'm literally just going to put this into my calculator. I'll show you. To do this in test mode, we're going to go over, right now it's on main. You can switch this main to ABC or to function. You can switch it back and forth. So you switch it to function, and you can see underneath the sine, cosine, and tangent at the top is the sine inverse, cosine inverse, and tangent inverse. So what I'm going to do is hit sine inverse. I already forgot the problem. Sine inverse of 10 over 12. So I'm going to go back to main and hit 10 divided by 12. And boom, I have my answer, 56.44. And for these ones, they want us to round to the nearest degree. So we'll just say 56 degrees. Let's try that again up here. I'll go back to number 3. This is on worksheet 9. All right, so it says find the measure of angle P. So from angle P, I have the adjacent side and the hypotenuse. So A and H means cosine. So cosine of the unknown angle, I'll call it x, equals adjacent 6.7 over hypotenuse 8.3. And what I need to do is cancel out cosine. So I'm going to inverse it. And then I have to inverse the other side. 6.7 over 8.3. I'm going to go to my calculator. I'm going to go to function, cosine inverse. I forgot. 6.7 over 8.3. 6.7 over 8.3. And I get 36.17, so 36 degrees. And that's it. So that's how you can use sine, cosine, and tangent to find missing sides and angles. Hopefully this video helps.